14-minute break. Get the new stuff. So there's 10 minutes left, so people still working. If you're planning to continue at 7:20, then there's no reason you can't take a 10-minute break now, or at a time of your choosing, rather than going to the last minute and going right into new material. You can pick your own stop time. That's fine, right there. Break time.
It's better to do it later and take your time.
Yeah.
Instead of trying to
Keep
rush.
Stay relaxed. morning, Kaylee, that drink is very addictive. I went down that road. Too late, no, too late, sorry.
It was the first drink I had here, so.
Too late.
Yeah, we got it.
The sheet's on now. It'll warm up.
It's very cold outside. It's very cold outside.
It'll warm there.
Very windy.
Hey, leave your phone on.
That's a smart move there, Steph. You stay a human being.
I looked at the back page and there's almost a bottom of it.
Oh, it doesn't stop, it never stops. Oh, 6 minutes restart.
Okay, cool, she's on it. The rainfall question? The rainfall question?
Oh, yeah.
We can do it, right?
I don't think so.
Woo! For the win! Oh.
Way to hit him.
There was a chart, a nice little flow chart, sometimes they're on
He
this
would do
question.
that to us. Yes, he would do that to us. He would do that to
So
us.
I looked
I
at the
felt
flow
like the
chart.
big one was where it had like the
No.
squiggly line around the
Leave,
directions.
leave.
It was like,
trust.
read.
Yes, it was that one.
Yeah, and I was like sitting here looking, and I was like, I feel like there's a reason that was supposed to read that.
I read through every single one of the equation pages to try to find it. He didn't put it in there. Well, kinda yes, kinda.
He did.
Is
It's on
that this
the
one?
chart, it was the flow chart.
Yeah, that's what I did, I did the flow chart.
Yes. He
I
did
double
put it in there.
checked, cause I was like, I read it and I was like, I bet you don't have to do this one, but then I just double checked and like, the
Yeah,
flow
you
chart.
can feel it, yeah, you can feel
Yeah,
it.
I was like, I don't think you have to do this.
Not normally distributed in endless blocks. No.
Yeah, that's what I put for my reasoning.
I put pretty much exactly what the
Believe in
instructions
yourself.
said.
yes.
I did too. I like copied and pasted, but then I put my reasoning behind it, like, this is why I thought this.
Oh, I didn't put reasons.
Makes me
Thank
feel
you,
better.
ma'am.
I'm just thinking.
We're under the stapler, all the same place. So, page 412, we will restart.
We're good, we're solid.
I'm glad you are so sure of yourself.
I'm feeling 100%.
Confident. Yes.
I'm not.
I don't think I did
one.
terrible. I think I did
This
that
was
C.
this was the big one, I feel like.
It was the big one.
I feel like this was the easiest.
This was the big test. You feel like this is the easy one?
I do.
Boy, you really messed it up.
You're so funny.
You feel this is easy. Well, for you, it was easy. Okay, I'll grant you that. It was. But yeah, this was the biggest test for most students.
Yeah,
This was
this,
the
I
big
could
one.
feel, this was the step 200 monster, I could feel it.
How do you feel after defeating that monster now?
I feel like
Did you defeat that monster?
Yeah, I feel like I am probably gonna keep on going with my not 100 streak, but.
Good answer. Avoid the trap. Welcome back.
But you passed.
Yes,
You
I
like
feel like
to
I
pass.
passed, I feel like I passed.
Okay.
I feel like I probably won't have to take this class again, so I'm happy.
So you mean you will not have to, you will not pass this way again?
You wanna hold these, right? You wanna hold these, right?
No, just put them aside, please. I mean, we're all honorable people.
Wow.
Well, this comes from my training. In fact, McDonald's is worldwide, I might have told you, and they expanded into the Philippines, and they gave very, very excruciating training to their staff. So I walked into a Philippines McDonald's, and this big smile and this, can I help you, sir or ma'am?
You're so
That's-
politically correct.
That's a mechanical robot, like kind of,
I have
Totally
a fun
trained.
story that doesn't leave this room.
you sure you wanna tell it?
I guess I'm gonna tell
Are
it.
you sure?
Cameras on.
Okay.
Alright, so.
Cameras on.
So correct.
Second out our silliness.
I like.
Leave that one in just for this class.
Have you tried these before?
Somebody I know,
Viral.
cough, cough, cough. Somebody I know was putting somebody on a plane and said, "This way, ma'am," and she flipped out and went, "Did you identify my gender?"
Are you serious?
No.
Yes.
We've been talking about that the past
This
few
must have
days.
been in recent years.
This was less than a month ago.
Yeah, this was recent.
Did you
Her
just assume
entire
my
unit turned
gender?
around and started laughing at her.
This way, ma'am.
She got
is wrong?
triggered. She
I
was, she got
don't
triggered.
get it,
People-
man.
People are getting mad because people in customer service are assuming people's genders now.
I'm sorry.
You can only go on what.
There are
what
certain
you can see.
indications.
Yes.
You know,
People are stupid.
All I'm saying is that.
No, I don't understand.
Ridiculous. People are ridiculous.
It's all.
So what would you
So
say,
what do we
this
do
way
with
person
everybody
or
on
something?
the
Is that what
They-
you-
Well, see, but they haven't
You mean
created the gender neutral.
Yeah,
that's-
that's-
I'm the only one that put it in
I'm
twice.
not
Right.
saying that,
Person.
I'm not saying,
Right,
I'm not
so
taking this
this-
aside on
But
it,
it's still rude.
but they did obviously
Yeah.
have
We don't
their
wanna call you
gender
ma'am.
training, so she probably was,
Alright,
you know.
yeah, well, I messed it
Popped
up,
up
I
on
mean, they
gender
got a new
training.
person that.
You know,
Burger
I haven't
King,
taken-
and
I haven't
really
taken
thought
that
they were
gender
the
training.
opposite.
Oh, you have to say?
So we got 60 more seconds of.
Oh.
I look at it every
frivolous
day in my
fun
inbox and say,
nonsense.
I don't
Are
want
we
to
back?
gender training.
You got 30
60
seconds,
seconds.
30
Alright, cool.
seconds, use it, 30 seconds.
Because I think it's the dumbest
Second.
thing on the planet.
start
Said
using
we're
the
12,
word
right?
person. It
Yeah.
should be person.
Okay,
Do
yeah,
you want to,
That's a
have
good
you
way to
tried
get
this before?
fired.
It's
okay.
super dark chocolate almonds.
Unfortunately,
It's
that's
like
it.
when I have a, no, it's like when I have a
People get
chocolate
triggered.
craving, right?
They get triggered easily.
And I think
What's the
it's-
matter?
so they're so strong.
Okay, 10 seconds.
You have like
Trigger
two,
warning.
and
Except
then
for
your, the
12,
chocolate
correct?
craving's
Nine,
better because
80,
it's
page
so.
412, please. 412, page 412. Okay, we're back.
We're back.
Congratulations for taking a hard test. 2 people are gonna wrap it up after 7:20. Otherwise, Grace will be back in a week as usual. So, the test 4, sorry to talk about this so soon after you just took a test, will be the last day of the class
How's
in
that?
9 days. Test 4, in 9 days. And I have the sheet here for you. These are the remaining assignments. This will be the material for test 4. And
Thank you.
then I will personally email to you your score on test 4 and your grade in the course within 1 week after that. So that's the way we'll handle the mechanic code. Please go to your Leo website and evaluate this course. I think I might have mentioned there are 5 or so questions on there. Multiple choice about myself, teachers are sharp, those are things like that. And then you get free form. You can write whatever you want to. So, now, don't wait till the course is over because they block you out. So sooner the better for an evaluate the course. Okay, I'm going to talk about a subject now near and dear to no one's heart. It's called
Not even
hypothesis
yours.
testing.
Oh, this is gonna get even more.
And it is the second most frequent use of statistics. The most frequent use, of course, is polling. This is a close second, where you have a hypothesis and you want to test it by statistics to find some evaluation of it, hypothesis testing. So certainly you have to start with a hypothesis. And it's frequently used in industry all the time. For example, is this Pinto gas tank really causing explosions and people to die of burns? That's a hypothesis. Or in research, are these mice really dying of this cancer? So hypotheses are very often formed in scientific research, and they need to be tested. So in order to test a hypothesis, you need to have a hypothesis. So I'm going to lead you through it. Everything starts with a claim. Somebody makes a claim. So I'm going to supposedly claim that the mean height of people is 70 inches. I claim that. Now, I haven't gotten to a hypothesis yet. We have to get to that in step 3. So this immediately leads to an anti-claim. That mu is unequal to 70 inches. So we've established that much. Now, we have to get into the hypothesis aspect of it. We're going to choose one of these to be the hypothesis that we test. And it doesn't always have to be the claim. It always is the one with the equal sign. So H0 is nomenclature for the null hypothesis that we're going to test, and it's the one that has the equal sign. So we're going to test the hypothesis that mu is actually 70 inches. The one that we don't choose to test is called the alternate hypothesis. H1. And it will be that mu is not equal to 70 inches. And we're now about to proceed with our test. So, I'm going to draw a complete set of sample means. Distribution. And the mu of the complete set of sample means is the mu of the population. And I want to test that the mu of the population indeed is 70 inches. So I enter that in my graph. Now this is a normal distribution. So 95% of the samples will be here with a z of +2 and a z of -2. 95% of the samples will be in that region, agreed? And 0.25% will be over here, and 0.25% will be over there. So did we cover it? Where all of the samples are going to be distributed, agreed? Now I'm going to take one sample. I'm going to take one sample. One sample. And my one sample will have an X bar. Now, I would expect my X bar to occur in this region. Why would I expect my X bar to occur in that region? Because 95% of all samples will occur in that region, because it's a normal distribution. So therefore, I expect my sample X, mean X bar, to occur in that region. Everyone understand? Good. I don't expect it to occur over here. I don't expect it to occur over here. And I don't expect it to occur over there. Why don't I expect it to occur over there? Because probability is very low, agreed? So the probability is very low. So I take my sample, and lo and behold, it occurs over here. What am I to interpret? Well, the first interpretation is that 0.25%, 2.5%, why don't you guys save me? I'm trying to get you to save me. You wouldn't. 2.5%, agreed? And the other one's also 2.5%.
If you don't write the percent sign, you were right.
You don't read it right, it's written
Not
right.
even.
Okay, now,
Good try.
if my sample occurs over there, then I can say, well, 2.5% of the time, it's expected to occur over there, agreed? I expect it to occur over there 2.5% of the time. This being the mean. However, let's suppose that the mean was actually over here at 75 inches. then my sample would then be in a populated region, would it not? If my mean was actually 75 inches, would I be much more likely to get this as my one sample, if the mean was actually 75 inches? Well, let's give this an actual value. Suppose this was 82 inches. Would you expect a sample mean of 82 inches if the mean of the population is 70? No, but if the mean of the population was 75, then would you not be surprised at a sample of 82? So I have two possible interpretations. One, this is a naturally occurring result of low probability that the mean is still 70. Or two, this is more likely to have occurred if the mean is not equal to 70, but is some higher value would be more likely to occur. So what I'm going to do is decide that if my sample does occur in the red zone, I am going to go with this one. And I'm going to reject the null hypothesis on the grounds that if the null hypothesis is true, only 5% of samples will occur in that region, and that's too low an occurrence for me to believe the null hypothesis. So if my null hypothesis occurs in this low probability region, then I'm going to choose to reject the null hypothesis that the mean is 70. Now, I have to swallow and realize that 5% of the time, or 2.5% of the time, I would be dead meat, I'd be wrong, agreed? It would have been just a naturally occurring low percentage result, with this being the true mean. So I have to make my result is that I reject the null hypothesis that the mean is 70 with a 5% significance level, or a 95% confidence level, as you say it. Meaning a 5% significance level, meaning I know that 5% of the time I should not have rejected it. That 5% of the time this result would have occurred naturally. And I'm stating that in my conclusion. With a 5% qualification, I'm rejecting the null hypothesis. I could be wrong. 5% of the time this would have been a natural result. But I have decided, before I took this sample, that if the result would had a less than 5% probability, I was going to reject the null hypothesis. I decided that up front. Just like you decided up front in polling where your confidence level was going to be. Here we decide our critical value is 5%. If we achieve a result that had a 5%, less than 5% probability of occurring, we're going to use that to reject the null hypothesis. To reject the null hypothesis. So the steps that you do in hypothesis testing is, first you draw a graph. Then you decide on your alpha level. What's alpha? Alpha is the probability below which you will no longer believe the null hypothesis is true.
So
5%, or 1%, or 10%. So you accept your alpha. That gives you, that allows you to color the red part of the graph. Allows you to color the red part of the graph. Then you take one sample. That one sample will lead you to a z-test, which is the result of the sample. And it will be mu, it will be x bar minus mu over sigma over the square root of n. And you plot that one sample on your graph. And this is called z-test. Z-test. And if that one sample falls in the red zone, you reach a conclusion. I reject the null hypothesis. That's the result of your hypothesis test. Because your one sample fell in the red zone, which you declared before you took the sample, then you reach a conclusion of rejecting the null hypothesis. Now, suppose that your one sample did not fall there, but suppose your one sample came out to be 71 inches. That's no longer in the red zone, is it not? Right. So what you now do is what we expect you to do.
Same step,
Hmm?
same steps.
Well, we go through the same steps, and we realize that it is not in the red zone. So if it was in the red zone, we rejected the null hypothesis. Now our test is no longer in the red zone, so what's our conclusion? Hmm?
So,
Doesn't mean could do something.
Anyone for say it in their own words? What would we conclude? So I'm gonna try to trap you one more time.
The claim is right.
If our result is in the red zone, we reject the null
We
hypothesis.
accept the hypothesis.
Wrong.
Stop. I'm sorry. I
You don't do anything.
I set you up. If your result is not in the red zone, you fail to reject the null hypothesis.
That's the
You
same
can
thing
never
I said.
accept the null hypothesis on the basis of one sample. It's too weak. You can never take one sample and conclude that the mean is 70. But
Just
you
fail.
can say that I can fail to reject it. This is the same in a court of law, agreed?
Right.
When the verdict is read by the jury, what are the two possible results? Either the defendant is guilty, or what is the other
Not
result?
guilty.
Not guilty.
They never say innocent, do they? Because you cannot prove innocence. You can either say guilty or fail to prove guilt, agreed? The same as here. You can either reject the null hypothesis or fail to reject it, but you can never accept the null hypothesis because you just took one teeny-weeny little sample. And that's far insufficient to accept that this indeed is the mean. So you do have the ability to reject the null hypothesis at the significance level that you have chosen, 5%. And if you do not get a result in the red zone, then you can fail to reject the null hypothesis. So the things that you have to do are decide what your alpha level is, which gives you the red zone in your graph. Then you have to take your one test, which gives you a z-test, and you plot your z-test on the graph. Now, one thing you have to do before you can decide if you're in the red zone or not is you have to know where this borderline z is. And you already know that many times from your polling results that this is at the 95% plus 1.96, agreed? The critical value for 95% on both sides there is 1.96, or you can look it up in your graph. Now, suppose that you got not a result of 82, but suppose that you got a height of 51 down there. What do you now conclude? Reject, because you're in the other red zone, agreed? Just as bad, because this is what's called a two-tailed test. If the hypothesis is that this is exactly 70, then we could be wrong because it's too high, or we could be wrong because it's too low, agreed? In other words, it's too far from 70 in both directions. So this is called the two-tailed test. Hi. Now, I'm going to lead you to another type of claim. The proportion of people who believe in global warming, the proportion of people that believe in global warming is greater than the proportion is greater than 60%. The proportion of people who believe in global warming is greater than 60%. That's the claim. Notice it's not a mean anymore, it's a proportion. Now what's the anti-claim?
Portion is less than or equal to 59%.
P is less than or equal to 60%. Now, I'm going to choose one to be the hypothesis that I test. Which one am I going to choose to be the hypothesis that I test? P is less than or equal to 60%. Notice you don't always test the claim. P is less than or equal to 60%. Now, I'm going to prove to you in a moment that it's sufficient to test that P is equal to 60% because that also includes the same result for anything less. So that's the one that we're going to claim. Now, just for the record, what is the alternate hypothesis?
The P is greater
That P is greater than 60%. So, Tony, what's the next thing we do?
We draw a graph.
If you insist, I wouldn't have done it myself, but I'll follow you. Now, on this graph, we are going to test whether the mean proportion is equal to 60%. Agreed? Now, I'm going to declare my red zone. Agreed? Now, my red zone, I have to look at these tests. First, I am testing whether P is less than 60%, agreed? So if I get a mark down here of 20%, that passes, doesn't it? Because it's less than 60. If I get a mark of 10%, that passes because it's less than 60. If I get a mark of 0.1%, that also supports this because it's less than 60. Conclusion, there's no red zone on the left. There's no red zone on the left side. The entire red zone is on the right side. Because if I get a P of 97, is that less than or equal to 60? No. So I reject. Agreed? If I get a P of 88, that's not less than or equal to 60, so I reject. Agreed? So my only red zone is on the right side. So what I'm actually testing is P equals 60, but I use these arrows to tell me where the red zone is. And the red zone is only on the right side because all less thans yield to a fail to reject. So this is a one-tailed test on the right side. So now I have to take my sample. And suppose I get a z-test, and I put my z-test on the graph, and if my z-test comes in this region, first I need a z-critical. So z-critical, z-critical. So this is 95% only on the high side. So what is z-critical for 95% only on the high side? Equals 1.645, which you also know, because that's 95% to the left, agreed? So I get my z-critical from the fact that I have a one-tailed test with 5% in it. So turn to the back of your book and look at these three numbers in the lower right-hand corner. For a 95% test, critical value, well, these were for two-tailed. That's not going to help you. We need the one-tailed. Okay, now, I perform my z-test. And suppose my z-test is 2.1. What do I do? My z-test is 2.1. What is my conclusion? Reject.
Yes.
Because 2.1 is in my red zone, agreed? Suppose my z-test is 1.7, what do you do?
Reject.
Reject. Suppose it is 1.1.
Reject.
Fail to reject.
Fail to
Fail
reject,
to reject.
because it's not in the red zone, is it?
No, it's 0.86.
No, this is my z-test, the result of my sample. It's not from the book. This is, I take one sample, test. Okay? Now, suppose my z-test was minus 9.7. way down here. What do? Fail to reject. It's very conclusive that the P. Now, notice how the claim and the anti-claim comes in. Which one were you testing? You were testing the anti-claim, agreed? You were testing the anti-claim? And you failed to reject the anti-claim. What does that say about the claim? That you're supporting the claim. You're supporting the claim. Because you failed to reject the anti-claim. Or no, in this case, you failed to reject the anti-claim, agreed? So that means that you are supporting the claim. You failed to reject the anti-claim, which you tested. So you failed to reject the anti-claim, which means that you're supporting the claim on the basis of your test. Okay. So, doesn't seem right. But you have a very low C test.
We're all
You have a very low C test.
It's the opposite wording,
Shouldn't
I
it be
think,
that
right?
if we're
supporting the anti-claim.
We are testing the anti-claim,
Yes, but,
and we are failing to reject the anti-claim.
But
We're
it's-
failing to reject the anti-claim.
So we would reject the claim.
We're failing to, yeah, so we.
Okay.
Thanks,
Lots
Mark.
You're like-
of words.
I knew I should have had a swig of coffee.
That's why I was
Okay,
like.
so you guys are catching on really well. Okay, so let's walk our way through it. On page 412, then on page 413, you see the three graphs in the margin of 413. The top one is when you decide to take a two-tailed test. And that is when the null hypothesis is strict equality, agreed? Somebody's saying this is equal to something. Then it could be wrong on either side. So you have reject zones high and low. But if somebody is saying that this is less than something, if you're testing whether it's less than something or not, then if you're testing, if your hypothesis is that it is greater than a certain value, and you get a very low result, then you have to reject that hypothesis. So you have a left-tail test. Now, if your hypothesis is that you're looking for a very low result, and you get a high result, then you have a right-tail test. Now, I'm going to show you the way you don't have to understand anything about what I just said. We have decided what the null hypothesis is. It's the one that contains the equal sign, agreed? Then you write down the alternate hypothesis. Not hard to do, is it? The arrow in the null hypothesis points to the tail. The arrow in the alternate hypothesis points to the tail. So you don't have to understand or believe. You just have to see which way the arrow goes. If the arrow in the alternate hypothesis points to the right, then do a right-tail test. If the arrow in the alternate hypothesis points to the left, do a left-tail test. If the arrows in the alternate hypothesis are both of them on equality, then do a two-tail test. So the one that we did a moment ago, we had a claim that mu was equal to 70. Since it has the equal sign, it became our hypothesis. And the alternate hypothesis was that mu was unequal to 70. These two arrows tell you to do what kind of a test?
two-tailed
Two-tailed test. So let's do a real life example. going to approach it in smaller steps. Okay? So let's go to our first part of the homework. So let's go to page 423. Looking at number 9. Please tell me what the claim is.
Mu is greater than 60,000.
Mu is greater than 60,000, agreed? So what's the anti-claim?
Mu is less than or equal to 60,000.
So which becomes our null hypothesis? H0 is, mu is equal, the one with the equal sign becomes the null. Which one has equal sign? Mu is equal to 60,000.
Less than or equal to.
No,
Oh, I'm
because
sorry.
we cannot test less than. I kept it one time to convince you that less than is included. If you test for equal, you're at the same time testing for less than. But you cannot test for a region. You can only test against a single number. You can't test against a region. So we have to test against the limit of the region, which is the equality. So we test against the equality. So that means that H1 is equal to the one that we didn't accept, which is what?
Mu is greater than 60,000.
So is this a right-tailed or left-tailed or two-tailed test? It's a right-tailed test. Don't have to understand anything. So Tony, what's the next thing you do?
Draw a graph.
Now, we're going to assume that alpha equals 0.05. So that means I have to draw my reject region, and where am I gonna draw it? Right here. So alpha equals 0.05, with a one-tailed test, so what's my z critical gonna be?
1.645.
What is it?
1.645.
Good. So we know it is z critical, agreed? So Freddie, what's the next step in our hypothesis testing? Sample, take a sample. We now take a sample.
Yeah, I took a sample, that's what, yeah.
I read the line. And from the sample, we find a z-test. Okay? Now, suppose the z-test comes right here. What's your conclusion? Fail to reject. Fail to reject. Suppose your z-test comes right here. What's your conclusion? Reject the null hypothesis. Now, when you reject the null hypothesis, it's very complicated how that relates to the claim. So our author has given you one of his beautiful flowcharts. This is perhaps the best one in the book, or certainly in the top 3,
414?
probably. 414?
Yes.
No, yes, it's 417.
My bad.
Okay.
There's two.
Now, if you don't want to use this, you can think it through logically and get a headache. Or you can use this chart to state your final conclusion about the claim. Now notice, the hypothesis was not included in the claim. That was a technical decision that you, the statistician, made. So you cannot state your conclusion in terms of something you created. The outside world doesn't know about that. They only know about the claim. So you have to state your conclusion in terms of what? The original claim. So this is how you go backwards from the result of your hypothesis test to put it in terms of the original claim. So let's see what we're going to do with this result right here. I'm going to assume that this was my test result. So this led to a rejection of the null hypothesis, did it not? This led to a rejection of the null hypothesis. But let's see how we're going to publish our result to the world. Let's go through this flowchart. So Tony, can you read the first instruction?
Does the original?
No, start.
You know, it's funny, I almost said that too, and then I was like,
Paragraph above it.
Anyway,
Start.
go where you want to. Does the original claim contain the condition of equality? Did the original claim contain the condition of equality?
Original claim.
No, it did not, did it? The anti-claim contained the condition of equality, so which way do we go? No, original claim does not claim the equality, okay? Next diamond is, did you reject H0?
Yes.
We did reject H0, therefore our conclusion becomes,
The sample data the sample data supports the claim that.
that mu, now you go back to the problem and you put in the magic words. Go back to number 9 on the page.
The sample data support the claim that the mean annual income of employees who took the statistics course is greater than $60,000.
Exactly. So you see how it reversed itself twice. First, you didn't even test the claim, you tested the anti-claim, and you failed to reject it, so therefore you're supporting the original claim. Like it? You like hypothesis testing? So you're supporting the original claim, agreed? Now, so the sample data support the claim that the mean income. So let's go to number 10. The proportion of people is equal to 0.20. So claim, P is equal to 0.2. So the anti-claim is what?
It is less than.
It is unequal to 0.2. So now, which one becomes the H0? Claim, P is equal to 0.2. And H1 becomes, P is unequal to 0.2. So Tony, what do we do next?
Jogger.
Now, is this a one-tailed, two-tailed, or three-tailed graph? Two-tailed graph. So we have 2.5 here and 2.5 here. And now, Freddie, what do we do next?
Sample.
Take a sample, and suppose our sample comes out right there. We failed to reject the null hypothesis, agree? So now, Steph, lead us through the flow chart and tell us how we publish our result.
Okay. So
417.
does the original claim contain a condition of equality? Yes.
Okay, so you know it.
Do you reject the H0? No.
Did we?
No. we
No,
don't.
so what did we do conclusion?
There is not sufficient evidence to warrant rejection of the claim that, that the proportion of people aged 18 to 25 who currently use illicit drugs is equal to 0.2.
In other words, you cannot say that we support this, because you can't go that far on one test. But you can say there is not sufficient evidence to warrant rejection. And that's as far as you can go. Now, these conclusions were written by lawyers. And you have to go just up to the line and not over the line, otherwise you get sued. So you can't do things that is not supported by your test. So all you can say is there's not sufficient evidence to warrant rejection, because we failed to reject, agreed? So there's not sufficient evidence to warrant rejection. You can't say, it's true, we proved it, there's just not sufficient evidence to warrant rejection. And so these things have to be stated in the double negative. So this flowchart tells you how to state your conclusions in terms of the original claim. And they're written by lawyers to protect the company from liability. Okay? Now, you're going to use this flowchart quite a bit. And now the part that we have skipped over was Freddie's part, where we took a sample test. And we now have to approach that in reality. How do we take our sample test? And from the sample test, how do we generate a z-test? Well, first thing that we have understood is that for means, we know that z is equal to x bar minus mu of x bar over sigma of x bar, which turns out to be x bar minus mu over sigma square root of n. So if we're dealing with a mean, we know how to take the z-test value. But if we're dealing with the proportion, then z is equal to the proportion in your sample minus the proportion in the population over the square root of pq over n. Okay. And this is on page 412. Good. Now, let's study this example to see how this calculation is made. So let's go back a page to 411, at the bottom of the page. Let's again, example 4, let's again consider the claim that the X-sort method of gender selection increases the likelihood of having a baby girl. Okay, now, what is P, which is the proportion in the population? It should be 1/2, agreed? 0.5? That's the standard probability of having a girl? Okay, now what they're claiming is that their proportion is greater than that, agreed? They're claiming that their proportion is greater than that. Okay, Okay, so what they're claiming is that they have some kind of pill that you can take that will give a proportion greater than 0.5 of girls, agreed? They're claiming that you can do this. So that's the claim. So what's the anti-claim? That P is what?
Less than.
Less than or equal. In fact, the anti-claim is just that P is equal to 0.5, standard population proportion, agreed? So which one of these is going to become H0?
The anti-claim.
P is equal to 0.5, and which one is going to become H1? P is greater than 0.5. So is this going to be a right-tailed or left-tailed test?
Right there.
So you see on the next page, 412, you have a graph in the middle that does have the right-tailed test for you. And we're doing this at the 95% confidence level, so the red zone has been blocked in. The only thing we have to do is take a test sample, like Freddie wants us to do, and generate z-test. So now, first let's take a gut feel. They sampled 14 couples that took the pill. And out of the 14 couples, 13 had girls. Would you guess in your heart that the pill is working?
No.
Why not? Out of 14 couples, normally you would expect how many to have girls? In this case, 13 had girls. So you already have a pretty good idea that we're going to support this claim, agreed? So let's go through the statistics. We're going to construct a sample test. So here we have the sample test solution. It is a proportion, so we use the z formula for a proportion. Z is equal to p hat minus p over the square root of pq over n. Now, what is the size of our sample? 14. And what are the number of successes? 13. So p hat equals 13 out of 14, then P is the background proportion that we're testing, which is 0.5 in the population, agreed? And so now you can plug in these numbers. And when you plug in these numbers, you get a Z of 3.21. So your Z is way out here. Tony, you didn't draw the graph.
Sorry.
So your Z is out here. Z test. Okay, Stephanie, when your Z test is out there, what is it that you do? Reject the null hypothesis, agreed?
Yep.
So remember what our claim is and anti-claim. So now let's go to the lawyer's table and see how your test leads to the correct lawyer ease. So Steph, lead us through it. The first diamond is,
Does, the original claim contain a condition of equality? Yes.
say it one more time.
Oh, no, it doesn't. No.
That's why you write these things down,
Yes. No, it doesn't.
okay? So
We
we
go
know
down.
next.
Do you reject the H0?
Hang in
Yes.
there. Yes. So what's our conclusion?
The sample data support the claim that
The pill works.
the pill works.
The sample data support the claim that the pill works. Okay. So these are the various steps. You write down the claim. Don't try to not do it. Write down the anti-claim. Don't try to not do it. Write down H0. Don't try to not do it. Write down H1. Then Tony suggests you draw a graph next. And then you block out the red zone. How do you know where the red zone is? What is it that tells you?
The arrow.
H1 tells you where the red zone is. And you put in the alpha number, which you convert to a Z critical, agreed? And then you do the Freddy's test. You have a sample. And from the sample, you get a Z test. And you see where your Z test falls, in the red zone or not in the red zone. So you either reject or fail to reject, then you go to the flow chart and make your conclusion. Okay, so let's have you test your ability to make a few test statistics. So let's go to page 424, number 25. Find the value of the test statistic in number 25.